Hi, in this video, we are going to cover how to read a roof truss drawing. My name is Chad Johnson. I'm with Truss Components. I've been in the truss industry for over 30 years, and I'm excited to talk to you about this topic. Hi, starting with the basics, one of the first things that we need to take a look at on the truss is what is the shape of it? So it might be a common truss, might be a scissor, which means that it would have a vault in it, but we're going to take a look at the shape of our truss and make sure that it aligns with what we expect it to look like. So in this case, I'm showing a gable end truss and diving a little bit deeper into the drawing. We start out with we've got our project number there. That should align with a layout. And so those will both be the same if we're looking at the right project. And so we can verify that we have the right project, and then we can start looking at our trusses individually, starting with the truss label. So this truss label A01, for instance, is going to align with our layout. And over here on our layout, we've got a truss A01. And so we can see that that's where this truss goes. So there's a lot of information on this truss drawing besides just which truss it is. So a few of the basic things. Let's go to a different truss drawing here that's a little bit clearer. That one's got some overlap. Okay, so this is the A02 truss. It's just next in line. It's this set right here. And so first off, we can see what is the span of our truss. And so the span is typically given in two different dimension lines. One is a cumulative and the other is individual points across the truss. And so this one here, that's our cumulative span of 31 feet. And so the way we read a dimension on a truss drawing is it's feet, inches, and sixteenths. So when we see that that says 3100, that means that it is 31 feet, 0 inches, and 0 sixteenths. So we can look over here at our layout, and here's that same dimension of 3100. And so that indicates that this truss span matches our layout here. In addition to the span of the truss, we also have the height of the truss indicated here. And so in this case, that says 8, 8, 14. And so that means that the overall height from the bearing point of the truss to the peak is 8 feet, 8 inches, and 14 sixteenths. That's what that 8, 8, 14 means. Other information that we have on this drawing is the pitch or slope of the truss. Now, the pitch is referred to in inches of rise per inches of run. And the common way that we look at that, the common denominator is 12. So this truss says it's a 512. And that means that for every 5 inches horizontally on the truss, every 12 inches horizontally on the truss, it's going to rise 5 inches. So that's a 5 in 12 slope. Another thing that we can see here is our overhang. So this says that the overhang, which is the portion of the truss that extends beyond the wall, the edge of the building, that is 130 or 1 foot 3 inches and 0 sixteenths. Overhangs are typically referred to in the number of inches, and so that's a 15-inch overhang. So far what we've covered is we've got our project number or job number, we've got our truss description, and then we've got our span, our height, our pitch, and the overhang length. But that is just scratching the surface. There is a lot more information here. So the information here says that our top chords are 2x4 dug for number 2, our bottom chords are 2x4 dug for number 2, and our webs are 2x4 dug for number 2. If we had a different truss in here with an individual that was different size, that would be noted in there as well. So the chord size, it's good to know It's going to be designed to meet the needs of the structure. But when we talk about the overhang, for instance, a 2x4 overhang is going to fit a different size fascia board than a 2x6 or a 2x8, for instance. So it's good to know what the sizes are on those. Uh, Additionally, we have a bunch of loading information. So we start up here in this note. It shows our loading and it's in pounds per square foot. These are uniform loads that are on the truss. And so our top chord live load is 25 pounds, which is the roof snow. And that is a very typical top chord live load for snow here in Western Washington, where we're recording this video. We also have a top chord dead load. The top chord dead load is the weight of the materials that will be on the top of the truss. So that would be roofing, solar panels, anything that's going to be there permanently. And it includes the weight of the truss itself. We've got our bottom chord dead load here, which shows 0 with an asterisk. And that's because we haven't added any additional bottom chord live loads, but there are some that are taken into account just in the code considerations. And those will be in the notes below. I can show those in a minute. And then we've got a bottom chord dead load of 8 pounds per square foot, which is the weight of the bottom chord, the ceiling, the insulation, those things are electrical fixtures that might be attached. So that is our basic loading information. Some things that you might find down in the notes would be special loads, concentrated loads for HVAC equipment. You might have girder loads if you have other trusses tying into this truss. But this is the basic loads up here. A lot of information that is on this drawing isn't going to be especially pertinent to an installer, but it's very important for those of us that are building the trusses, or if we're an engineer that is reviewing the designs, and that is things like the plate size and orientation. So this indicates that at the top of the heel of the truss, this is going to be a 5-inch by 5-inch plate, and the teeth are going to be orientated vertically. So we've got the plate information. If this was a multi-ply truss, we would have some notes about how it's going to be fastened together as well. And additionally, and this is very important, we see what our bearing points are on the truss. And so let's go to a different tool here. And this is, oof, that's a big line. That is our exterior bearing. I'm going to make that a little smaller, a little more opaque. And here we go. So there's one exterior bearing. And then over here, we have a symbol that indicates a hanger. So that truss on one end is sitting on a wall, and on the other end is sitting on a hanger. This will be important when we relate this to our layouts, but this is our left end on the drawing. So over here on the layout, we can actually see a triangle on the end of that truss. I'll zoom in a bit, and that triangle indicates the left end of the truss. And that's actually here in our notes. We can see a triangle on the layout indicates the left end of the truss. So that means that this left end of the truss over here is represented by this wall and this end of the trusses. And so our top of wall bearing is on that end. And then we're connecting to a girder truss over here where we show a hanger. So this is relevant to our placement plans. So our placement plans, like we've alluded to, they show where each truss goes based on the label of the truss, A1, A02, A03, and so on. And different companies will use different labeling conventions. So what we call an A01 truss, that doesn't mean that every time you see an A01, it's going to be a 31-foot truss with this profile. That just happens to be what we use for this layout. But the layout indicates where each set of trusses goes. And so we're looking over here at the A02 on the right of our screen, and we can see that there are 11 of those on this part of the layout over here. So going to that B04 truss, we can see that that shows the hangers here that were represented on the right side of that A02 truss that we were looking at. And so each point where a truss is tied into it, it shows a hanger. And then down here in the notes, it will have the other information that we talked about, such as the connection of the trusses. So that shows the nailing pattern for the top and bottom cords, as well as the webs. And then it'll have some more information. For instance, here's a special load. So this truss was designed for a drag load of 230 pounds per lineal foot. And that drag load transfers forces from one part of a structure to another. So these are the engineering notes that we're going to see. So we talked about that live load of 25 pounds on the top cord, the dead load of 10, and the bottom cord dead load of 8. Some of the other things that we see up here in the notes are our deflection information. So the deflection is how much that truss can basically like bend or sag under the loads that are imposed on it. And so we can see that the deflection is very minimal on this truss. The code says that a truss can deflect up to 1/240th or 1 inch and 240 inches of span under total load. And you can see here that it is deflecting less than 1/999th of that span. And I misspoke. It's 1 in 240 for live load, and it is 1 for 180 in dead load. Some of the other things that are noted, let's go to a different truss here, see if we can find, there's some bracing called out right there. So these little triangles, or I'm sorry, these little boxes here indicate where a permanent brace goes. So that's something to keep a lookout for on your truss drawing. So essentially, carpenters would want to focus on installation details, spacing, bracing, that sort of thing. Builders need to know the layout, where each truss goes, and to make sure that they fit the profile of the building. In addition to information like the plates that are holding the truss together and the fasteners that might be holding multiple plies of a truss together, other information that is on the truss layout is the spacing. And so this tells us what the frequency of the trusses is going to be. Another bit of information is the spacing, and this tells us how close together the trusses are. And this is typically referred to as feet on center. So 2 feet, 0 inches, and 0/16 is the spacing on this particular truss package, which aligns with the layout that says that the trusses go 2 feet on center. That is standard, but that's not what every truss package has. Sometimes they are closer or further apart. And so that's important to note. Also, occasionally on a truss layout, you'll have an odd dimension. This building happens to be 50 feet wide, but if it was 49 feet wide, for instance, somewhere on that layout, there would be some trusses that were 1 feet on center in order to make up that difference. And so that is referred to on our drawing here. It's very important because that is the way the truss is loaded. What it's designed to carry is based to a large degree on how far apart the trusses are. So this was pretty much just a surface level review of how to read a truss drawing. Important things are to be able to recognize which truss you're looking at, verify that it goes with the job that you're working on, and then check things like the dimensions on the truss, which are laid out in feet, inches, and sixteenths to make sure that the truss is going to fit the building. Recognize the profile of the truss to make sure that where that truss goes on the placement layout, it aligns with the shape, the aesthetics of the building at that point. And then being able to look down in our notes and determine what our live loads are, our dead loads, our deflections, as well as connections from truss ply to truss ply, and any special loads that those trusses are carrying. Each person in the process has a different set of information that they may be focusing on. The builder might be looking at the trusses to verify that they're the correct shape. Also, what the architect might do. A carpenter would be looking to make sure that they have the trusses placed correctly in the field and braced properly for the long term stability of the structure, that sort of thing. And an engineer might review the drawings to make sure that all of the correct loads have been applied and that they have been taken into account for. And so all of that information is here on the truss sheet. It can look a little daunting at first glance, but once you pull it apart, it's just a bunch of individual bits of information. And of course, if you ever have a question about the information that's on the truss drawing or just need a little bit of tutoring on how to read it, you can always reach out to your truss manufacturer. We're always happy to walk through a truss drawing with a customer to help them better understand it. We'll see you on the next video.